Sam Wasser and colleagues realized that the same tools they used to match ivory to an individual elephant could be used to determine which elephant population in Africa a shipment of ivory most likely came from. The first step was to construct a genetic map of elephant populations throughout the continent. To do this, scientists extracted and analyzed DNA from over 2,000 dung samples from 81 elephant populations.
The green X's are where we have forest elephant samples, and the orange are where we have savanna elephant samples. Populations across Africa differ genetically by how far apart they are and how long they've been separated. So what happens is DNA is always mutating in populations, and the farther apart you are and the longer you're separated, the less likely that mutations from one population are going to get into another. So when you have enough genetic markers that you use, we use 16 of them, you're able to actually characterize those genetic differences that have evolved over space and time. Based on all of those 16 markers, you can start to say that the DNA at all the loci we're looking at here have diverged enough in this population from this population that I can reliably pin that individual as being from this population versus that.
Wasser and colleagues mapped the allele frequencies of the 16 markers and all the populations from which they had collected DNA. They then used that information to estimate the frequencies in populations for which they had no samples.
So now I can take an ivory seizure and I can assign it to within 300 kilometers of where it came from anywhere in Africa.